Okay. In the meanwhile, if anyone has any questions also, you can let me know, guys, before we get started. In the last class, which I took on Sunday, we have taken a brief demo on what the course contents are, what topics we'll be learning throughout the course. In today's session, we're supposed to talk about networking fundamentals, the first prerequisite for the course. Okay. We'll be covering what IPv4 addresses are. We'll be covering again different categories of IP addresses. What are public IPs? What are private IPs? What are some important protocols in it? What is DNS protocol? What is DHCP? Okay, so all of this will be covered in the again the duration of the first few classes, the first 2-3 classes. Okay, so any questions or doubts regarding cybersecurity before that? How many of you have joined the session this Sunday, the demo session this Sunday? And how many of you are new to the session today?
Yeah, I'm new to the session today. I didn't join yesterday. Sorry.
Oh, okay. No worries. Hello. Lawal, I suppose. I'm pronouncing that right. Am I?
Yeah, that's fine. Yeah.
Yeah. So that session is available on YouTube itself. You can search for
Okay.
DURGASOFT cybersecurity, filter
Okay.
it out by the recently uploaded ones, and you can find the session. Okay. So
Okay.
again, we just
Thank you.
took a brief demo on again the entire course, Certified Ethical Hacking version 13. What is the procedure that we'll be following? What tools we'll be working on? Okay, and the entire hacking cycle. I've discussed the course content and the syllabus and stuff. So again, nothing, you haven't missed out any of the actual classes, you've just missed the demo. Okay,
Okay.
nothing
Thank
to
you.
it. Okay, so yeah, let's get started without any further ado. As mentioned in today's class, we'll be going with networking fundamentals. But before that, if there are new students today, let me give you a brief introduction on my end. My name is Mohammed Shoaib. I will be your cybersecurity trainer for the entire duration of the course. And again, I've been working with DurgaSoft for the last 4 or 5 years, and I've been in this domain of cybersecurity for the last 7 years. Currently working as a senior penetration tester, and again, work based in India itself. Okay, and we'll be learning this course called Certified Ethical Hacking version 13. This is the first course that you're supposed to take in order to get into the domain of cybersecurity. It explains everything from scratch, understanding what hacking is, what ethical hacking is, what is the procedure to perform either of those, okay, and what tools you'll be working on in real time. Since I have the expertise of working on these tools in the same industry, I'll be showing you everything in real time, hands on the same applications which are used in real time today. Okay. So before we dive into all that, there's a few important prerequisites to understand what is networking, what are Linux commands, what is virtualization, how do you set up the lab environment. We'll be covering all that first before we dive into the actual course. Okay. So today, let's talk about what networks are and what IP addresses are. Okay. So when we talk about networking, there are three important definitions to know. What is networking? What are networks? And what are hosts? When we talk about networking, this is the practice of connecting information devices with each other. So in an organization, you have multiple sorts of endpoints or devices. You have your routers, you have your printers, you have your switches, you have your client operating system desktops, you have your servers. Again, different categories of servers: web servers, FTP servers, DNS servers, DHCP servers, okay, mail servers, okay, then IP cameras. So the process of connecting these information devices, whichever I've listed out, okay, with each other so that they can share information or resources with each other is called as networking. Okay. Now these devices can either be connected in a wired format or in a wireless format. Okay. So now when you talk about a network, on the other hand, it is the collection of those devices. So when you have a list of devices connected with each other and which are capable of communicating with each other, that's called as a network. Okay, the group of devices which can communicate or transmit data to each other. Okay, and in an organization, you can either have one single network or you can have multiple networks. Okay, and among these multiple networks, also there can be communication established. Okay, and in each of these networks, we have something called hosts. Okay, so from here on, I won't be referring to them as devices. I'm going to call them as hosts. Okay, so a host refers to any device or any information system which is connected in a network that can transmit or receive data. As explained or as mentioned already, examples of your hosts are printers, routers, mobile phones, computers, web servers, okay, IP cameras, smartwatches, whatnot. Okay. Now, just like how we humans have our names to identify each other, these hosts also have names. and that name is called as an IP address, Internet Protocol Address. Okay, this was invented by the US military in the late 1950s or 1960s. Okay, and again it was built for the process of communicating or establishing communication between different military posts. Okay, so when you wanted one military again a post to communicate with the other one, that is the main sole purpose or the necessity of inventing IP addresses. But later on, it got transgressed into the other actual worldly applications as well. Okay, so later on, it was implemented in organizations for devices within a company to communicate with each other or across companies or over the internet as well. Okay, so but primarily it was built to establish communication between two military organizations or two military locations, I would say. Okay, to define an IP address, it is again basically an identity or an address or a name given to each host on the network. Okay, it's a unique identifier and it stands for Internet Protocol Address. Okay, these IP addresses allow for communication to occur between the hosts or between the devices. Now, when they were invented, there were multiple versions of it. Okay, there was or multiple iterations of it. There was IP version 1, IP version 2, IP version 3. They were quite experimental. They didn't succeed in again being pushed into the real world applications. What successfully transgressed or what successfully got implemented was Internet Protocol version 4, IPv4. And this IPv4 address has some important properties to it. Okay. So IPv4 stands for Internet Protocol version 4. And we're still using IPv4 addresses in today's world as well. Although these were invented in the 1950s or 60s, we still use them today in our world. Okay. So firstly, let's talk about some important properties of this IPv4 addresses. Okay. So when you talk about IPv4 addresses, this is a 32-bit address. What I mean by a 32-bit address is that it contains 32 zeros and ones consecutively. Okay. A bit is the smallest value a computer can hold. It can either be the value of 0 or it can either be the value of 1. Okay. And your IPv4 address is a combination of 32 zeros and ones. Okay. It's a 32-bit address. Okay. And this entire 32-bit address again is divided in four equal parts, where each part or each portion can contain 8 bits in it. And each of that 8-bit portion is called as an octet. Octa is the representation for the number 8. Okay. So each bit, again, so each of that 8-bit portion is called as an octet. And each octet again is separated by a dot symbol. Okay. So you have the first 8 bits, then you have a dot, then the next 8 bits, then a dot, then the next 8 bits, then a dot, and then the next 8 bits. So in that format, you have the entire 32-bit IPv4 address. So what you see here, the language of zeros and ones is called as the binary language. This is what computers generally communicate, language of zeros and ones. But we humans don't understand this binary language so well. What we regularly use are decimal numbers. So now I'm going to show you how do you convert any binary number to a human readable decimal number. Okay. So this number here, 11000000 is actually equal to 192. Okay, so don't worry how to convert that. I'll explain that in a minute now. But again, this is the computer readable language and this is the human readable language. Okay, then this number 10101000 is actually equal to 168. This number 1010, sorry, 00000000 is actually equal to 0 itself. Okay, and this number 00001010 is equal to 10. Okay, so now I'll be showing you how do you convert any decimal number into a binary number and vice versa. Okay, so let's say we take this number here 10101010. Okay, now we'll be learning what is the step-by-step procedure to convert this number into a human readable decimal number. And I'll also explain why this is important in a minute. Don't worry. Okay, but let me start explaining now. So firstly, when you want to convert a number like this from binary to decimal, you have to write down the values of 2 power 0 all the way up to 2 power 7 from right to left. Okay. So under the rightmost bit here, write down 2 power 0. Okay. Then 2 power 1. Then 2 power 2. Then 2 power 3. Then 2 power 4. Then 2 power 5. Then 2 power 6. And then 2 power 7. So assign the power of 2, which is from 2 power 0, all the way up to 2 power 7 from right to left. irrespective of what bit you have on the top, what value you have on the top. Just write down these values from right to left. Okay. Once those values are written down, then multiply the lower value with the top bit. As simple as that. 2 power 0 into 0. And after that, add it with the next one. Plus 2 power 1 into 1. Plus 2 power 2 into 0. Plus 2 power 3 into 1. Plus 2 power 4 into 0. Plus 2 power 5 into 1. Plus 2 power 6 into 0. Plus 2 power 7 into 1. Now, this might seem a bit mathematical here, but I'm going to explain why this is important, guys, in a minute. There's a very important logic here. Okay. So whenever you have any binary number like this, to convert it into a decimal number, a human readable number, this is the process for it. Write down the values from 2 power 0 to 2 power 7, and then multiply the lower number with the top bit. Okay. So first, let me write down the values of these numbers first. Anything to the power 0 is equal to 1. It's a mathematical rule. So 2 power 0 is 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 raised to the power of 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. Now that we have these values here, we can substitute them here. 2 power 0 into 0, that's 0, plus 2 power 1 into 1, that's 2. 2 power 2 into 0, again 0. 2 power 3 into 1, 2 power 3 is 8, so 8 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. So now that we have all these values, if we add them up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer understands it as 10101010. Something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. When that exact sequence of frequencies flows through a computer, it understands it as the number 170. Okay, so that is how you can convert any machine level data into human readable data and vice versa. Okay, is that clear for everyone? Any questions or doubts up to this point? Ankit, Anuj, Abhishek, Ashish, Ao, Jaiprakash, Sundar, Veera. Any questions, guys? Excuse me. Hello. Please do not hesitate to let me know if you get stuck somewhere. Is this clear for everyone?
Yeah, thank you.
Yes, that is. Ankit, clear for you as well? Any questions or doubts up to this point? Ankit? Okay, perfect. Now, the reason I'm explaining you all this, guys, is because from this conversion, you can actually understand the first IP and the last IP range. Okay, so if I had to get the first IP, all I have to do is put all zeros everywhere. So when I put all zeros, so 0, 0, 0, 0, 0, 0, the simple binary to decimal conversion would be simply 0 itself. And when I put all ones, so let's say if I put all ones here, like an example 2 here, you can see I've put all ones. Okay. So when I've all ones here, so 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1. If you add all these numbers, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, when you add all that up, you get the number 255. So from these calculations, actually, you can figure out what the first IP is and what the last IP is. If I have to get the first IP, I have to simply put all zeros everywhere. In the first octet, all zeros. In the second octet, all zeros. In the third octet, all zeros. In the fourth octet, all zeros. So when I put zeros everywhere, first IP in human readable language is simply 0.0.0.0. And if I have to get the last IP, how do I get the last IP? By putting the maximum value everywhere. And the maximum value can be obtained by putting all ones everywhere. Okay, so in every octet here, I've put all ones. So when I put all ones, we get the number 255. So the last IP is 255.255.255.255. That's the last IP. So according to the, again, binary to decimal conversion, we can actually get the range of IP addresses. The first IP is 0000, and the last IP is 255.255.255.255. It cannot exceed the number beyond 255. Why so? Because in an octet, when you put all ones, the maximum it can obtain is 255 itself, not more than that. Okay. And if you have to count how many IPs are there in total, each bit over here has two possibilities. And there are 32 bits in total. So 2 multiplied by 32 times like that. So 2 raised to the power of 32. 2 into 2 into 2 into 2 into 2, 32 times. So when you raise 2 to the power of 32, you get the number 4.3 billion IP addresses. So from this first IP till the last IP, there are a total of 4.3 billion IP addresses approximately. When these were invented in the late 1950s or the late 1960s, that was a very large number because back then you didn't have mobile phones, not many people owned computers. So 4.3 seemed like a very large number back then. But fast forward to 2025 today, the population itself is close to 9 billion people, and each person again can have multiple devices. So these 4.3 billion IPs would not have been sufficed if you assigned each IP individually to each device. So that is why these 4.3 billion IPs are again divided in multiple categories. Oh, yeah. Was someone asking a question? Yeah, Ankit. Which section? Come again. I didn't talk about subnet mask yet, Ankit. We haven't covered subnet mask yet. Where did you hear about subnet mask? That's the last IP. Yeah, that's the last IP. That's not the subnet mask. That is the last IP. So in order to get the last IP, you just have to put all ones everywhere. We haven't talked about subnet mask anywhere. Okay. It's only about the last IP. The first IP, if you have to get the first IP, put zeros everywhere. And if you have to get the last IP, put all ones everywhere. When you put all ones, you get the last IP as 255.255.255.255. Okay. And if you have to get the total number of IPs, it's all about possibilities. How many possible IPs can you get? Okay. And every bit here has two possibilities, 0 or 1. And there are 32 bits in total. So if you have each bit with two possibilities, and if there are 32 bits over here, total number of possibilities of IPs are 2 raised to the power of 32. 2 into 2 into 2 into 2 into 2 into 2 into 2, 32 times. That is 2 to the power of 32. That is why 4.3 billion IP addresses. Okay. Is that clear, Abhishek? Why is it 2 to the power of 32? Because you have 32 bits over here. Each bit has two possibilities. So 2 to the power of 32. It's I think, a permutations formula. Okay, 2 to the power of number of possibilities, which is 32. Okay, right. Moving on after this. So now we know this is the first IP and we know this is the last IP here. So what about the IPs in between? How is the sequence of IPs flowing? Let's talk about that. So to understand the sequence of IPs, there's a very simple logic, guys. Sequence of IPs can be understood by these two simple rules. Always start incrementing from the rightmost octet. That's the first rule. Second rule is once the rightmost octet reaches the maximum value, move to the left octet. Now, it might seem very gibberish, it might seem very confusing. Let me explain this in detail. Okay, so we know the first IP is simply 0000. Okay, if I have to get the next IP now, according to rule number one, always start incrementing from the rightmost octet, which means whatever value is there in the rightmost octet, increase it by one. Okay, so if I have to get the next IP is 0001. Okay, so after 0000, next IP is 0001. Rightmost octet is incrementing by one. Okay, next IP after that 0002. Next IP 0003. Next IP 0004. This goes on all the way up to 000255. After 000255, you cannot have a value like 000256. That is not possible. maximum value an octet can get is 255 only. Okay, so now comes rule number 2. Once the rightmost octet reaches the maximum value, then you move to the left octet. So this 255 goes back to 0, it cycles back to 0, and the next octet, the octet left to it, is incrementing by 1. So after 0 0 0 255, it goes to 0 0 1 0. Okay, this is something very similar to your speedometer in the vehicle, guys. Okay, so in your new if you purchase a new vehicle, what would be the speedometer be looking like? So if I just show you this with a simple diagram. So in the olden days, this is what the speedometer looked like, if you remember. Yeah, you see this one? Mm. Yeah, this looks good. Uh, yeah, this looks good. So if you see this numbers here, 0 0 0 0, right? So if that is the first value, what would the next value be? So you have four numbers like this. Okay, so there are four places, let's say, or four columns. Okay, so you have 0 here, then 0 here, then 0 here, and then 0 here. Okay, okay. So let me put them symmetrically here. Much better. Oh, just a second. Yeah, much better. Delete, delete. Okay, so let's say this is something like your speedometer. Okay, now after you drive 1 kilometer, so this is the first value. Okay, after you drive 1 kilometer, what happens next? Let me increase the font a bit large. Yeah, 0 0 0 1. Okay, so this is your next kilometer reading. Okay, after this, what happens? 0 0 0 2. Next 0 0 0 3. Next 0 0 0 4. Okay, this goes on all the way up to 0 0 0 9. Okay, after 9, what happens now? You have 0 0 1 0, right? So this 9 cycles back to 0, and the next octet increments by 1. Same logic here as well. So if the first IP is 0 0 0 0, next IP would be 0 0 0 1, next IP 0 0 0 2, next IP 0 0 0 3. This goes on all the way up to 0 0 0 255. Okay, after 255, so this is something like 0 0 0 255. So 0 0 0 9 is something like 0 0 0 255. Okay, what happens after that? 0 0 1 0. Okay, so this 9 cycles back to 0, something like 255 cycle back to 0, and the next octet, next value changes to 1. So 0 0 1 0. Okay, so after 10 kilometers, what happens next? 0 0 1 1, 0 0 1 2, 0 0 1 3, goes all the way up to 0 0 1 9. What happens after 1 9? 0 0 2 0. Same logic here as well. After 0 0 1 0, you have 0 0 1 1. Okay, so always increment the rightmost octet, rule number 1. Okay, then 0 0 1 2, 0 dot 0 dot 1 dot 2, then 0 dot 0 dot, oh sorry, yeah, 0 dot 0 dot 1 dot 3, then 0 dot 0 dot, this goes all the way up to 1 dot 255. After 1 dot 255, you have 0 dot 0 dot 2 dot 0. Okay, same thing which is shown over here. 0 0 1 0, 0 0 1 1, 1 2 1 3 1 4 goes up to 1 2 5 5. Then 2 0 2 1 2 2 2 3 goes up to 2 2 5 5. 3 0 3 1 3 2 3 3 goes up to 3 2 5 5. 4 1 4 2 4 3 4 4 goes up to 4 2 5 5. The cycle goes on and on and on. And somewhere down the line, you would have 2550, 2551, 2552, 2553, then 2555. This is something like 99 kilometers. After 99 kilometers, what happens? You have 100 kilometers, something like 0 dot 1 dot 0 dot 0. Okay. So after 0 0 255 255, all the 255 cycle back to zeros, and the next octet increments by 1. Okay. So after something like 99 kilometers, Oh, sorry. So after 0.099, okay, something like 0.0.255.255, you have 0.100. Okay, so which is similar to 0.1.0.0. Okay, so that 100 again goes up to 1.0.255. Okay, then you have 110. Okay, so again, so after 0.100, you have 0.101, 101 kilometers, 102 kilometers, 103 kilometers, goes up to 109 kilometers. Okay, then you have 110 kilometers. Okay, very similar to 0.1.0.1, then 0.1.0.2. Oh, sorry, then 0.1.0.3, which goes on all the way up to 0.1.0.255, and then 0.1.1.0. Okay, this 255 cycles back to 0, and this next 0 increments by 1. Okay, 1, 0. Okay, this goes on all the way up to 0.199. Okay, something like 0.1.255.255. Okay, and then you have 200 kilometers, which is like 0.2.0.0. Okay, so wherever there's 9, just replace it with 255. Okay, and you automatically get the cycle. So after 11255, you have 120. Then it goes up to 255, then 30, which goes up to 355, 40, which goes up to 455. This goes on and on and on. And somewhere down the line, you would have 0200. Okay, the 0200 goes up to 0225525. 300 goes up to 3255255. 400 goes up to 425255. 25500 goes up to 255, 255, 255. Okay, so this is like 0999 kilometers. Okay, and then next you have 1000 kilometers, which is 1000. Okay, so whatever cycle repeated from here, from 0000 to 0255, 255, 255, same thing repeats from 1000 to 1255, 255, 255, then 2000 to 2255, 255, 255, from 3000 to 3255, 255, 255, 4000 to 4255, 255, 255, and finally down the line, this will go up to 255000 to 255, 255, 255, 255. And this is the entire sequence of IP addresses from the first IP till the last IP. And if you count each and every single IP, you would have a total of 4.3 billion IP addresses. So that is the entire sequence. Okay. Might seem a bit confusing, guys, but that is how the IP addresses transgress one after the other. Okay. Or progress one after the other. Okay. Any questions, any doubts up to this point? Ashish, Abhishek, Devashish, Govind, Prakash, Shiba, Veera, Ankit. Now, there's a reason I'm explaining you all this as well, guys. We'll be talking about why it is important in a while, okay? Or probably in the next class, okay? But yeah, this is the entire sequence of IPs, okay? And again, as mentioned, this entire 4.3 billion IPs are again divided in various categories. There's something called as classes, class A, class B, class C, class D, and class E. And again, in each class, you have two separate categories, public and private IPs. Class A has public and private IPs in them. Class B has public and private IPs in them. Class C also has public and private IPs in them. Class D and Class E are exceptions. They are only public IPs in them. There are no private IPs. Okay. Today, we'll be ending the class with the last discussion. What are public and private IPs? In the next session, we'll talk about the classes as well. Okay. To understand public and private IPs in the simplest format possible, let's take the example of our home network itself. Okay. Now, in our home network, we usually have a Wi-Fi router. Okay. And to this Wi-Fi router, we have multiple devices connected. We have our laptops connected. We have our smartphones connected. We have our smartwatches connected, our smart TVs connected, or other desktops connected. Okay. All of these devices are connected to our Wi-Fi router. Please note that all of these devices are called as intranet devices. Intranet in the sense, a local network devices. These devices are private and local to our network. Okay. So this is my own private network, my own individual network, and this is not connected to anybody else. Okay. So such networks are called as intranet networks. Okay. And when any device in an intranet network wants to communicate with other devices, There we go for private IPs. So private IP addresses are the addresses used in the intranets. When you want to communicate one device with the other device on a local network, in a private network, for that we use the private IPs. Okay, but that is not usually the case. You would want to communicate with the internet as well. So your router gets a cable from outside your house. So whenever you set up an ISP connection, the internet service provider guy from Airtel or Hibernate or Geo or whatever it be brings a cable from outside the house and connects to your Wi-Fi router. That cable, which is an optical fiber cable or an RJ45 cable, your Ethernet cable, okay, carries the public IP, and that is provided to you by the ISP, internet service provider. Okay, so the internet service provider is someone who provides you the service of internet with the help of public IPs. So public IPs are the IP addresses used on the public network, which is also your internet. Okay, when any of your devices in the home network wants to communicate with the internet, they have to send the packet to the Wi-Fi router first, and the Wi-Fi router gets access to the public IP from that cable, and with that public IP, it sends the data to the ISP. And from the ISP, it goes to the other different servers on the internet. So let's say if your phone wants to communicate, excuse me. Yeah, let's say if your phone wants to communicate here with a website like google.com, first your phone sends the traffic from its own private IP to the router's private IP. Okay, so from 192.168.0.4, it sends the packet to something like 192.168.0.1. These addresses are your private IP addresses. Okay, then your router is capable of transmitting that data from the private network to the public network. A router is a device which is capable of transmitting data to two different networks. Okay, so it can send data across different networks. Okay, so from the private network here, it sends the data to the public network interface. Okay, and from there, with that public IP, the packet goes to the internet. Okay, and from the internet, it reaches the exact server google.com. Okay, so this is how public and private IPs are used or interchanged to send data across the internet. Okay, so private IP addresses, as mentioned, are the addresses used within private networks, okay, or intranet networks, such as home networks, offices, organizations, etc., etc. For local communication, you always go for private IPs. These private IPs are not directly accessible from the internet. You cannot use just a private IP to connect to the internet, guys. That's a very important point. Okay, these only allow devices to communicate within the same local network. Okay, so only devices within the same local network can communicate with each other using private IPs. Okay, and if you want to check what your private IP is in a Windows system, you can open up the command prompt. You can search for CMD in Windows, and you can run a command ipconfig. It stands for Internet Protocol Configuration, and this shows your private IP. So I'm connected to my Wi-Fi router here, and this is getting the private IP 192.168.0.2. Now, why specifically 192.168? We'll cover that in the next class. Okay, I'll talk about what this range is, what is subnet mask, what is default gateway. I'll explain all this in the next session, guys. Okay, and on the other hand, when you talk about public IPs, these are globally unique IP addresses which are used to identify devices on the internet. So when any device needs to communicate with the internet, it needs a unique IP, that is the public IP. Okay, and these are allocated only by ISPs, internet service providers, organizations like Airtel, Act Hibernate, Hathway, Reliance Geo, okay, Vodafone Idea. All of these are ISPs in India. If you go to US, you have ISPs like T-Mobile, Verizon, Mint Mobile, AT&T. All these are ISPs in the US. Okay, so these IPs, the public IPs, are routable over the internet. They're assigned by the ISP, and they can send data across multiple servers on the internet. And if you have to check what your public IP is, you go to your browser, and in the browser you search for what is my IP. Okay, and with that you get a lot of websites here. As you can notice, these websites will show you your public IP. Okay, you can click on any website. So if I click on the first link here, you can see this is my public IP here. This is provided by my ISP called Beam Telecom, which is at Hibernate, and in the region Andhra Pradesh, India. This is my location. Okay, so this is how you check your public IP, and this is how you check your private IP. And no matter what IP address you take, you can notice all the numbers are between 0 and 255. They cannot exceed the number 255, no matter what IP you take. Okay. So that is what IP addresses are in general. Tomorrow, again, we have discussed about what public and private IPs are today. We have also discussed about how to convert a decimal number, sorry, a binary number to a human readable decimal number. Firstly, what is networking? What are networks? What are hosts? What are IPv4 addresses and their properties? Okay. What is the first IP? What is the last IP? We got all that from the conversion from binary to decimal. And then we talked about the sequence of IPs. And then we talked about the public and private IPs today. Tomorrow we'll cover what the classes are. What is class A? What is class B? What is class C? What is class D? What is class E? What's the relevance of each of these classes? Okay. Why do we have 5 separate classes? What's the importance of each of them? We'll cover all that in the session tomorrow. We'll also be covering what subnet mask is and what are important protocols like DNS and DHCP protocols. So very important topics, guys, in the next class. We'll cover this in the upcoming sessions. Okay. So yeah, that's that. Nothing further. Any questions or doubts before we exit the session today? Ankit, Abhishek, Ashish, Veera, Debashish,
Same
Govinda,
time tomorrow.
Sundar. Yeah, Veera.
Yeah, yeah. So actually, this is my first session.
Uh-huh, uh-huh.
Yeah, actually, I think there is also an introduction session for the cybersecurity, or else
Yeah,
it's a
we took that yesterday, Veera.
yeah.
So that session is available on YouTube actually. We took it yesterday. It's recorded and it's uploaded on YouTube. You can access it from there. Okay. And we covered what cybersecurity is, what hacking is, what ethical hacking is, what tools we'll be working on, what is the procedure that is followed by cyber professionals. I've covered all that in the last class.
Okay. So like, what's the difference? Like, there is also SOC, right? SOC, and also for the cybersecurity. It's I think there is some level one SOC analyst and all. So
Right.
what's yeah.
So this course is more focused on NOC, Veera. So in your cybersecurity, you have two subdomains, SOC and NOC. Okay, NOC stands for Network Operations Center. SOC stands for Security Operations Center. NOC deals with the penetration testing part, finding vulnerabilities in various devices and managing those vulnerabilities and patching and all. And SOC deals with data, basically data security. Whatever packets are coming in, whatever packets are going out, detecting threats through logs. Okay, all that is SOC, where you deal with SIM tools, security, information, and event management tools. This course is, I would say, 75 to 80% focusing on NOC, Network Operations Center, and 20% on SOC. Okay, we'll talk about how to analyze data as well. We'll be using a tool called Splunk as well in this course. Okay, but it's more focused on NOC itself compared to SOC.
Okay. So like it's total into like cybersecurity, right?
Into cybersecurity, yes. SOC is also a part of cybersecurity itself, but just a different domain in it, I would say.
Okay. So like
Right.
with opportunities in the cybersecurity is currently like as per I'm also working in one of the IT organization. So basically, we have been only seeing the SOC analysts and all at our glance in while in working in the organization. But cybersecurity professionals, like, do we have more opportunities in the cybersecurity? Like,
It's
how?
it's equal actually, Vera. So for cybersecurity, if you're going towards NOC, you would see more of a cybersecurity consultant or penetration tester job roles. Okay. For SOC, you see the SOC analyst job roles. Okay, they're equally important, I would say.
Okay.
All right. Okay. Any other questions or doubts, guys? Yeah, Ankit, I can hear you. Hello, Ankit. Yeah, I can hear you. Yeah, Ankit, I can hear you. Uh-huh. No, not really. In both public and private IPs, both will have static and dynamic IPs. It depends on how you're configuring them. Okay. So you can put static IPs in your private networks also. ISPs can also assign a static IP. Okay. If you want, you can put them dynamic as well. There is no such correlation between static and dynamic for public and private. Nothing as such. It's all about how you're configuring them. Yeah,
Uh,
Abhishek will be discussing that as well.
okay, like another question.
Uh, Yeah, there is a difference between a last IP and subnet mask. We'll cover that in the next class. Don't worry. So there's a very huge difference. We'll cover that. So I've not explained subnet mask yet. We'll cover that in the next session, Ankit. Last IP looks a bit similar to your subnet mask, but it is different. Okay. So just looks similar. It is not your subnet mask. We'll cover what subnet mask is in the next class. Yeah, Ashish, we'll be covering the certification CEH itself, Certified Ethical Hacking. So again, that is the exam you can write. You will be eligible to write. You'll be prepared to write the certification exam CEH version 13. Yeah, Ankit, go ahead. No, as mentioned, if you're planning on writing the certification, you can write the CEH certification, Certified Ethical Hacking version 13. Your voice is getting cut, Ankit. Cut. Sorry. Ankit, your voice is very unclear. Can't hear you properly. Or do one thing, Ankit, just drop your question on the WhatsApp. You have my WhatsApp number, right? So drop it there. I'm unable to hear you properly. I think there's some issue with your microphone. Not able to hear you clearly. Yeah, yeah, sure. Any advance? Again, depends on what job role you're applying for, Ashish. So again, as mentioned, depends. Again, if you're planning for a penetration tester itself, this is more than sufficient. If you're planning for SOC analyst job roles, there are other courses other than this. Wouldn't say advanced courses, but just other courses in the same domain. Okay. I'll be posting that once the students are confirmed, Ashish. The other student, Ankit, is confirmed. He's my reference, so I could share my number to him. But once you register with the institute, you'll be getting my number directly from the institute itself. I'm not given the permission to share it yet myself. Yeah, yeah, yeah. Again, I've been working in this domain for the last 7 years, Ashish. So if you have any questions, again, even beyond this course, you can let me know, and I'll be guiding you further in this domain. That shouldn't be a problem. Right. So yeah, that's that. Nothing further for the session today, guys. Please do join the session tomorrow as well. As mentioned, it's an important class tomorrow. We'll be discussing a lot more in-depth concepts on networking, which is quite
Hello, can
important
you hear
for
me?
cybersecurity.
Hello,
Yeah,
hello.
Lavan, I can
Yeah,
hear
I
you.
just is it same time tomorrow?
Yeah, same time, no difference
Okay,
in that.
thank you.
Same time, same link, same session. Okay. So yeah, bye bye. Good day, guys. See you tomorrow at the same time.
Thank you. Bye.
Thank you, guys. Bye.